Once upon a time, in a math class ruled by Darth Banks, Darth Banks gave pop quizzes using the dark side to our unexpected heroes. Those heroes?
Aimee Sky-watcher.
And Wookie Tookie Tho. In the near future, I shall give a pop quiz to Aimee Sky-watcher and that Wookie Tookie Tho. I will make them use numeric and geometric patterns to generalizations about geometric properties of polygons, ratios and similar figures and solids and angles, relationships in polygons and circles.
You must do these practice problems, young one. Here, do this one first. The length and the width of similar rectangles are shown in the table below. Which of the following rectangles is the rectangle listed in this table?
We are trying to figure out which rectangle is similar to the one shown below. Similar is when objects have the same shape but not necessarily the same size. The lengths of corresponding sides are proportional.
Master Yoda, what does proportional mean?
A proportion is two ratios that equal each other.
Master, what does ratio mean?
I need to find a numeric pattern, which is a numerical list in which the numbers are placed in a sequence between the length and the width. I will use the force. I got it. The number constantly being multiplied on the length side is 2. The number being constantly multiplied on the width side is 3. In the first row, you multiply the constants by 2. Second row, the constants are multiplied by 3. Third row, the constants are multiplied by 5. And the last row, the constants are being multiplied by 20.
A word from the rise, the smaller numbers in the table represent the lengths, so the smaller numbers for the squares are the lengths.
Thank you for that reminder, Master Yoda. To solve the problem, you have to first set the constants as a ratio, 2/3. Then you plug the answer choices in as a proportion, then cross-multiply. The mathematical force is telling me that the answer is B. At first I thought that the constant was just a number that length and width had to be divisible by. If I just went on that, I would have chosen A. Other young Jedis not as in touch with the mathematical force as I could just look at the first row and assume that the difference between length and width is just add 2, so they would have chosen C. The force is also telling me that the golden ratio was used in ancient Greek architecture.
That is correct, young one. Now you, Wookie Tookie Tho, here is your problem. How many diagonals can be drawn from one vertex of a 10-sided polygon?
Well, a vertex is the intersecting of 2 points of 2 line segments. Man, I don't know this.
Use n-3, whereas n is the number of sides of a polygon, and your answer is the right answer.
Take n and make it 10, so 10 minus 3 equals 7. So my correct answer is A, 7. Some distractors of the problem that I saw was that C, 10, because when you see the number 10, you automatically think it's 10.
Now you two are ready to take the quiz.
Yeah, let's do it!
I will now give them an English test instead. The equation to find the number of vertices is n minus 3, whereas n is the number of sides of a polygon. A hexagon has 6 sides, then you subtract 3 to get your number of vertices, which equals 3. An octagon has 8 sides, then you subtract 3 to get the number of vertices. That will give you 5. First you count the number of sides, then subtract 3. Then you get your answer, you jump up and say hip hip hooray.